Here we go again, new video, this time on some of the basics of rational numbers. Particularly, we're going to be looking at rational expressions, but we can't really do that until we define a rational number. When you look at the word rational, you see hidden in it the word ratio. Now, when I think of a ratio, I think of a kind of fraction. I say like 2:3. So a rational number is basically any number that can be written in the form of a fraction. Technically, we say a rational number is a number that can be written in the form P over Q, where P and Q are integers, and Q does not equal 0. For example, 2/3 is a rational number. It's the ratio of two integers. -5/1 is a rational number. We usually just call it -5, but because we could take any integer and place it over 1, they're all rational numbers. An example of something that's not a rational number would be something like radical 2 or pi. There's just no way to take these numbers and write them as fractions. With that said, I want to ask, why do I have that caveat in there that we can't divide by 0? Sometimes people will say dividing by 0 is like creating a black hole. It's a bad thing. Why? What I'd like you to do now is to turn off this video and search online and find some resources and study up on this a bit and write down why you think we can't divide by 0. Once you're ready, turn us back on. Next, we're going to look at what a rational expression is. What I want you to realize is what you just wrote about why we can't divide by 0, we're going to use as a springboard for discussion tomorrow. So it is not in vain. So back to what is a rational expression. Again, it's going to have to do with the idea of ratio and fractions, except now we're going to say a rational expression is any expression in the form P over Q, where P and Q are polynomials, and Q does not equal 0. Now, polynomial, we should think many terms. So, for example, 2x plus 3 is one polynomial over x squared minus 4x plus 2. That's another polynomial. Now, the number 3, even though it has one term, is a polynomial, and we could place this over x squared minus 4. Again, the ratio of two polynomials would be a rational expression. However, something like e to the x plus 3 is not a polynomial. E to the x is an exponential function. So even though I'm writing it as a ratio, it's not a rational expression. With this said, we want to now look at how to reduce rational expressions. I take that back. I'm one step ahead of myself. I want to say, when are rational expressions undefined? So for our first example, let's call this example A. I'm thinking to myself, when would 3x plus 2 over x squared minus 4 be undefined? Well, remember, the rational expressions aren't defined when the denominator is 0. So what we really want to know is, when does x squared minus 4 equal 0? To do this, I'm going to factor, noticing that this is the difference of two perfect squares, and I'm going to see very easily that if x is equal to plus or minus 2, sorry, that got a little messy there. In fact, that's going to drive me a bit crazy, so I'm going to erase that. Sorry. So if x is equal to 2 or x equals -2, this denominator will now become 0, and the entire rational expression will be undefined. So it's undefined at plus or minus 2. In your notes, I would like you to do example B, and that is, I would like you to tell me when AB squared over 3A minus 2B is undefined. So turn off the video and give this a shot. Now we want to reduce rational expressions. Before we reduce rational expressions, let's go back and review reducing rational numbers. Most of you are pretty good at this, and you know we just divide top and bottom by 2. When you first learned this, you probably talked about prime factorizations and said, you know, 6 has a prime factorization of 2 times 3, and 8 has a prime factorization of 2 times 2 times 2. When we cancel common factors, what we're really doing is dividing the numerator and the denominator by the same thing. So in this case, I'm dividing top and bottom by that common factor of 2, and I'm left with 3 over 2 times 2, which is 4. So you can see clearly that when we when we reduce, we should first factor and then cancel common factors so that we have our reduced answer. With that said, for example C, let's look at reducing x squared minus x minus 6 over 5x squared plus 10x. You should note that the top factors into x minus 3 times x plus 2. The bottom has a GCF of 5x, so it's 5x times x plus 2. Now we could see the common factor in the numerator and denominator is x plus 2. And if we divide out by that, we are left merely with x minus 3 over 5x. So when I reduce the original quantity, I get x minus 3 over 5x. I want to make a note here that these two are equivalent as long as x does not equal 0 or x does not equal -2. Because we have to be concerned, A, with where they are undefined, and 2, that although the final reduced answer has a 5x in the bottom, so it's defined at -2, the original was not defined at -2. With this said, I would like you in your notes to reduce the following 2 questions. First, 3 minus x over x squared minus 9. And second, 3x minus 3y over y squared minus 2xy plus x squared. See you tomorrow.